Hello, my name is Maria Francesca Raj,
And my name is Ramon.
and we are going to present our experience on applying Agile learning on the computer science laboratory subject at our university, the University of the Balearic Island.
We deeply regret not being able to present our work in person, but COVID restrictions still make traveling difficult and sometimes even impossible.
We have been teaching a programming laboratory course for 8 years. In this course, we were due to reinforce the programming skills of the students through practice. Our students were enrolled in a telematics engineering degree, and they already had a semester experience in the Java programming language.
Having in mind the engagement of the students in the subject, we proposed the development of a game for a mobile device. Besides, this embodies a set of interesting programming challenges that satisfies most of the requirements necessary to accomplish the reinforcement aspects of our course goals: object-oriented programming, networking with either Bluetooth or Wi-Fi, task synchronization, code optimization to reduce the response times, access to hardware facilities, multimedia content such as audio, image, and so forth.
For 2 years, we used a traditional sequential project-based approach where the students were asked to analyze the requirements, design the product, implement the software, test the software, to finally provide a running version. This approach clearly relates to a sequential waterfall process where a stage needs to be complete before starting the next one.
Although we had successfully used this approach for 2 years, we realized that in such a sequential process, the students started the development stage very late. And if we consider that this stage is the main road to achieve the course's goals, it might not be a suitable approach as a lot of time was devoted to previous steps. By no means we consider of lower importance the other phases, but we thought that its temporal distribution was not adequate. We also noticed a significant increase in the students' absence in class, possibly due to the fact that, as they exactly knew what to do by the end of the semester, they could do it without any supervision, at their own pace. Assistance to class were not required, but the main problem was that deviations from the project, due to the wrong design or implementation decisions, were often detected too late. This sometimes led to students' demotivation, as they had to rethink important components in their project.
As a result of these observations, we decided to shift to an agile learning methodology approach. This model, at first sight, could better fit the purpose of our course. Agile software development uses an incremental model based on the continuous planning and team collaboration that follows the cycle of software development in an incremental way. The cycles of requirements, design, building, testing, and delivering a project are no longer late sequential stages that need to be completed before starting the new one, but are incrementally updated so as to rapidly deliver working software to the customer.
At the beginning of the semester, the students freely choose a team partner to work together all along the course. As lecturers, we acted as the project customer. So, we could change design criteria on the fly to force the retrospective actions or to change the initial requirements.
In the first lecture of our Agile learning methodology approach, we explained the main goals of the course and we introduced the Agile learning methodology that we are going to use.
And we proposed a project that consisted in the development of a game application on an Android platform.
We proposed a different project every year. For instance, a puzzle application.
This project is the replica of the classical end puzzle solving, where you can only move a piece to the empty space till you complete the image. They are supposed to implement a series of functionalities, like a help option, a shuffle button, the possibility to change the image. The image can be changed either with a stored random image, with an image from the mobile phone gallery, or an image directly taken with the camera. Also, the puzzle size should be changed.
In that first lecture, we also provide the students with a proper view of the semester schedule. The semester duration is of 15 weeks. A week has two class sessions of 2 hours each and 6 hours of autonomous work. which corresponds to 6 ECTS credits.
The semester duration is divided in a fixed number of sprints. Take into account that sprint is one of the most characteristic trends in the Agile philosophy, and it consists on a short term during which a certain task or set of tasks has to be completed and the results obtained have to be delivered. Each sprint takes 1 or 2 weeks, depending on its complexity, and results in the delivery of new functionalities to the final product. The proposal of a sprint consists of a written document specifying the title, the goal, and the delivery date of the result.
Face-to-face class time was devoted to students' guidance and support, so as to the explaining of existing misunderstood concepts. When a sprint finishes, the students were asked to deliver their work in our online platform and the new sprint was proposed. We reviewed the delivered work and gave feedback to the students through the same platform before the new sprint began, so they had time to sort out detected problems. The frequent deliveries ensure fast and on-time detection of programming errors or project concepts. Student submissions are therefore synchronized, and the student deviations are easily detected, so support efforts can be organized in order to correct such situations.
By the end of the semester, the students are asked to deliver the final product and a report documenting their work. The report consists of a paper-like document where the students must describe what they have done, the main troubles they have faced, and how they have solved them. We have also included a section where they can express their opinion about the course development and finally a self-assessment of their work.
To analyze how the Agile learning methodology has affected the teaching of our course along the years, we have collected both quantitative and qualitative data. The qualitative data is extracted from the opinion section of the final reports of the students enrolled in the academic years, where we applied the Agile learning methodology approach from 2015-16 to 2020-21. We have also conducted an additional qualitative survey at the end of the last academic period, 2020-21, to specifically ask our students their opinion about their appreciation of the applied methodology.
The quantitative information is obtained using the academic information from the academic students' records of the complete longitudinal study. We have collected a grand total of more than 300 qualitative comments from more than 60 different teams. We have filtered the comments extracted from the student reports that we consider relevant for the topics of this paper, and let's see what they said.
A worth mentioning aspect is that the students have felt very comfortable working in pairs, and they think that this has allowed them to progress faster in the project. The importance of team working received a lot of comments. The teams also point out that working with time spans of 1 or 2 weeks has been a very positive aspect, because they easily detected and corrected the designing and programming failures early, and they could keep progressing without many problems. The students valued the lecturers' feedback, as somehow they felt more confident about their progress.
We found comments making explicit that they consider easier the testing in early stages, as programming errors were isolated in each sprint. While reading the comments, we realized that the students have relied on the daily work to deliver the sprint's result on time.
About concepts consolidation, some students report that they have deeply understood basic concepts as object-oriented programming and top-down design. An easy adaptation to the Agile learning methodology has also been widely reported.
About motivation, most of the students agree that in our course they have applied the concepts they knew to new challenging fields, such as graphical display, sound, images, animation, and mobile device programming, which has truly reinforced their skills.
About the choice of a gaming application, we have also received satisfactory feedback like, "Programming makes fun," or "I thought programming was a bit boring, but this app programming changed my mind."
Surprisingly, some of the students reported how proud they were about their work, even prior to know their final subject assessment. In fact, several teams even uploaded their final project to the Google Play Store. The feeling of satisfaction is also present in an important share of comments.
The survey proposed to the students in the last semester asked specifically about what they thought were the pros and cons of the Agile learning methodology, we have used when compared to the sequential project learning in other subjects.
What did they say? For instance, some of the comments were: if there is a mistake, it is easily detected. I positively evaluate the feedback. Goals are clearer. We felt rewarded when completing the sprint. We know exactly how we are performing. Continuous communication between teachers and students, and so on.
Some of the drawbacks note: we have to work hard to get every sprint delivered. The global vision of the project is not so clear when going by steps. We had limited flexibility. I had a false sensation of success when completing short tasks. When I missed a class, I stepped behind the rest. Probably those are the key points we could expect. Students are somehow pressed to deliver the sprints on time, and so they have to work on a daily basis.
The quantitative data we obtained from our own records and from the institution records are also meaningful. We represent them graphically. Let us start with the students' perception of their performance. We have used the data from all the academic courses from 2013 to 2021, and as we can observe, the student perceptions, the self-assessments, are not too far from the real assessments they get. However, we can see noticeable overestimation in the first 2 years, which corresponds to the cascade-based approach methodology. That's an expected result because they don't get any feedback till the final assessment, while in the Agile approach, they get feedback on their results after each sprint.
Class attendance records were kept, and this figure shows the comparison of the assistance to class rate for both methodologies: the traditional project-based, see orange color, and the Agile-based, see blue color approaches. As we clearly observed during the 2 first years, when sequential project-based learning was used, a student's assistance to class was lower than when using Agile learning. The fact that short-term deliveries are expected at the end of each sprint motivates the team's attendance, as they can get immediate support and validation to their design and programming decisions. Moreover, we have observed that when somebody was absent from class, his teammate was attending the class. Rarely, both of the team members were absent.
Finally, let's look at the final assessment mean by methodology approach. We can really rely on these figures to state that Agile learning provides better academic results, as of course this heavily depends on every year's students. But they can give a light insight into such an affirmation.
As a conclusion, we have presented the results of our long-term experimental work on Agile learning compared to the cascade nature of the project learning approach. From the qualitative data extracted from the final reports of the students, we can stand out some conclusions, both not directly and directly related with Agile learning. In the first category, we found positive comments about the thematic approach of the projects we propose. The students are motivated to apply their programming knowledge to new challenging fields, such as multimedia and mobile devices programming.
The students have felt very comfortable working in pairs, and team working has been largely and positively commented. The time spans provided by the division of the project in sprints is another positive aspect, as the students can detect and correct design and programming flaws in early stages of the project.
Personal motivation is highlighted from the data gathering. The students speak about pride and personal satisfaction with the results they get. The students claim an easy adaptation to this learning model.
A contradictory positive and negative comment is the daily work needed to complete the assignment, closely related to the frequent delivery of the results of the sprints. Successful reinforcement of programming skills is reflected when students talk about the understanding of basic concepts such as object-oriented programming or top-down design.
Albeit not being taken into account in the global assessment, the students' self-assessment significantly approach the final grades they get. This can be seen as if the students correctly perceive how they are performing. Quantitative information also leads to some interesting facts. Truancy rates are lowered, and the students are highly involved in the Agile learning project. Although it's not easy to rely on the data gathered from the assessment results, they seem to get better grading results.
Looking at the qualitative data of the survey we conducted, we could claim that the students are satisfied with the Agile learning methodology, being aware, of course, of the detected limitations.
Thank you very much for your attention.
That's all.
Bye.
Bye.